Hi dear students. So in this section we will discuss about the relative velocity. Relative velocity means the velocity of an object with respect to another object which is also moving with a particular velocity. Okay. So both the objects, suppose consider two objects A and B, both are moving uniformly. That means with a constant velocity and acceleration value will be 0. A body, if it is moving uniformly, that means the velocity value will be a constant and the acceleration value will be 0. So here the velocity of the body A is given as VA and the velocity of the body B it is given as VB. And both are moving in one dimension and in one direction. Consider both are moving in the positive x direction. Okay, but their velocity values are, one is VA and another one is VB. Both are moving with the various velocities, different velocity. So XA0 and XB0s are the position of the object at A and position of the objects A and B. That is the initial position. Initial position, let us take over here, that is both are same. Okay, XA and XB, that is at 0. Now suppose this body VA is moving with a larger velocity and VB is moving with a smaller velocity. Okay, so if you are considering after a time t, that means VA is moving with a larger velocity, so it can cover more distance in a particular time t. But at that time VB is moving with a very slow velocity, or the slower it is moving with a low velocity. So after a time interval t, it may reach till here. Okay, because VA is larger than VB. So for a particular time interval VA can cover more distance compared to that of the body B with a velocity VB. Okay. So here the position at the A at a time t is XA and position of B at a time it is XB. Now we have to find out the variation or the displacement between XA and XB, the difference in the in their path length, the path they have covered. So linear displacement that you have to take, so that will be XB minus XB minus XA, that is the, or XA, as XA is the larger value, so you can take XA minus XB. Okay, so you can find the XA at a t and XB at a t with the help of these two equations, that is XA at 0 plus VA into t, velocity into time, it is the displacement, because velocity is equal to displacement by time, so time into velocity will be is equal to displacement. So with this, with the help of this equation, you can find out the position of A and B at a time t, that is the value of XA and XB. Okay, where XA of 0 and XB of 0 are both are 0, because the initial point we have considered as same and that is from the origin, that is the 0. Now XA of t will be is equal to, which will, this is 0, so remaining is VA of t, and XB of t will be is equal to 0 and VB of t will be there. So XA of t is equal to VA of t, XB of t will be is equal to VB into t. Now as you want to find out the displacement between XA and XB, that is XB of t minus XA of t, or XA of t minus XB of t. In our condition we have considered the XA as the larger one, so XA of t minus XBT we can do, or else XB of t minus, that is the displacement between both the A and B bodies after a time t. So here you have to substitute those values that we have derived over here, these two values, instead of XA and XB you are substituting those values, then you will get XB of 0 minus XA of 0, both are 0, so it will be 0, and remaining VB minus VA into t, where this VB minus VA is known as the relative velocity of B with respect to A, which can be represented as VBA, that is the velocity of B with respect to A. As well, VAB, if you are writing VAB, that is the velocity of A with respect to B, that value will be equal to VA minus VB, and here VB minus VA is known as, that is the relative velocity of B with respect to A, and that is represented as VBA. Okay, so displacement from A to B changes steadily by the amount of VB minus VA in each unit of time. So that means the displacement between A and B after particular time interval will be changes with the velocity of VB minus VA. Okay, the displacement that we have found out here, that is this is the XA and this was the XB. So this displacement which will change with the velocity of VA minus VB. Okay, that is known as the relative velocity, or VB minus VA. Okay, so VAB is equal to VA minus VB, and VBA is equal to VBA is equal to VB minus VA. Okay, so this is the relative velocity of A with respect to B, and as well this is the relative velocity of B with respect to A. Okay, now let us consider, there are three graphs in your textbook representing the motion of two bodies A and B. In the first graph you can see that where the VB which is equal to VA, but their initial positions, okay, at time 0 the VB or VA is beginning from 10 meters, but VB is beginning from 20 meters. So XA and XB values are various, but you can see that both are parallel lines. That means the slope will be equal. That means the slope of the position time graph will give you the velocity. So VB will be equal to VA. So in such conditions, the graphs, if you are plotting the graph of two bodies A and B which are moving with the same velocity of V, that is VA is equal to VB is equal to V, we are taking like that. So VA is equal to VB is equal to V. So if both the bodies are moving with the same velocity, then the position time graph will for both the bodies, the position time graph will be parallel to each other. If you are drawing the position time graph of both the bodies in a single graph sheet, then both the bodies position time graph will be parallel to each other. Okay, so that is the first one. When VA is equal to VB, then VAB or the position time graphs of both the bodies will be equal. And what about as VB is equal to VA, the relative velocity VBA, suppose if you are finding out the velocity VBA, that is VB minus VA, but both the VB and VA are equal, so VB minus VA will be equal to 0. As well VAB also will be equal to 0 when both the bodies are moving in the same direction with the same velocity. The relative velocities will be equal. Now let us consider another one. In this one, the B, you can see the slope of B is less. That means VB is lesser than VA. And XA is lesser than XB at time t is equal to 0. That is XA of 0 is less than XB of 0. When velocity of A is greater than velocity of B and the initial position of A is lesser than the initial position of B, then at some point both the graphs will meet. Okay, where at a particular time the position of both the bodies will be the same. Okay, when VB is less than VA and XA is less than XB. XA and XB means at a time 0. You can see that here VA is greater than VB. From the slope itself you can see that VA is greater than VB, but XA is actually near about 10, but XB is actually near about 40. So XA is lesser than XB. Okay. So in such case the graph will meet at one point. Otherwise we can say at a particular time both the bodies will meet each other, and afterwards A will overtake B because the velocity of A is more than that of B. Okay. As well, a third one. Okay. So this one you can see A is moving in one direction, that is the positive direction. A is moving in one direction. B is the position diagram of B is you can see that it is from positive to negative direction, that is the slope is negative and it is moving in negative direction. The position is as the time increase the position is decreasing, so it is moving in the negative direction. In such cases also at some point they will meet each other when so XA, we can say the body A is moving with a positive velocity VA and body B is moving with a negative velocity VB. Okay. And if the XA value, that means the position XA of 0, if XA of 0 is less than that of XB of 0, that means the position at time 0. Okay, the position of A is, if the position of A is lesser than the position of B at time 0, then they will intersect at one point or they will meet at one point of time. Now one more thing, if you want to find out the relative velocity of A with respect to B, okay, means VAB, which is equal to VA minus VB, where you know that here the value of VB is negative, so minus of minus VB will be there, so that means VA plus VB. So the relative velocity will be very high if the bodies are moving in opposite direction. So the relative velocity, you can say if the bodies are moving in same direction, the relative velocity will be less, but at that time if the bodies are moving in opposite direction, the relative velocity will be very high. So these are the major things regarding the relative velocity. I think you understood these things. Actually this is very easy only. So you just read the textbook thoroughly and as well go through the example questions and the exercise questions also. The direct exercise questions you just try to do in your notebook, and the indirect ones we will discuss after October 1st. That means the revision time for this the first term examination. Okay. And take down the notes properly, and you have to submit the notebooks. I think you got the time schedule to submit the notebook. On that day itself you should submit the notebook. Okay, complete the notebook as soon as possible. Okay then, thank you very much.